Dynamic data structures are stack, queues, and linked list. And coming to the non-linear data structures are tree and graph. Tree and graph. So tree is a data structure which is a non-linear data structure. Which is a non-linear data structure. Okay. So when compared to the linear data structures, non-linear data structures are completely different. Okay. So they are not going to store in continuous memory location. They are not going to store it in continuous memory location. So it is going to store it in somewhere. So it is going to use in somewhere. So coming to the tree, so tree contains root. Tree contain a root. Okay. So for example, so go to something. So I will open the paint. So this is, let us assume this is a tree. Okay. So I'll store the element 30 and I'll construct tree here 20 and so 40. So let us assume this is a normal tree. Which contains some elements. So in this tree, so this one is called as root node. All are nodes only. But that 38th one is called as root node. A tree must contain a root node. And along with the root node, we have the child nodes. So these are child nodes. These are child nodes. And we have left to the root and we have right to the root. So there are so many types of trees. But most important tree is binary search tree. So most important tree is binary search tree. So we call it as BST, binary search tree. So binary search tree is a tree. What is a tree? A tree is a non-linear data structure. So what is the use of this data? So the and retrieve the data efficiently. Okay. So tree is a data structure and non-linear data structure which is used to store the data and retrieve the data effectively. So one of the important tree is binary search tree. So what is a binary search tree? So binary search tree is a tree which contains set of elements. All the elements must contain root node. So what root node must contain and left to subtree. We call it as subtree. And right subtree. Left subtree and right subtree. Okay. So in a binary search tree, all the nodes which are left, and all the nodes which are right. So all the nodes which are left are called as left subtree. All the nodes which are right to the root node is called as right subtree. Okay. The root node element
and left subtree elements and right subtree element must be placed in a order. Must be placed in a order. So what is the order? What is the order? All the left tree element, all the left tree element should be less than to the root node. Should be less than to the root node. All the left subtree nodes must and should be less than the root node. All the left nodes must and should be less than to the root node. And all the element from the right subtree or the element from the right subtree should be greater than root node. Should be greater than root node. Okay. So left subtree element should be lesser than the root node. Right subtree element should be greater than the root node. So it is called as binary search tree. It is called as binary search tree. So for example, we have some element 10 comma 20 comma 30 comma 40 comma 50. So let us assume these are the elements. These are the element. So to this element we have to construct
search tree. To this element, we have to construct binary search tree. For example, for example, first element 10. First element 10. So we will place the 10 element here. We will place the 10 element here and we will compare. We will compare. There is no element for the first time, only single element. So 10 is there. So we will not compare whether it is less than the root node than less than greater than the root node. So only one element is there. We will consider that one element will become the root node. So what is the root node now? What is the root node? The root node only 10, single value. Suppose next, what is the element? 20. What is the element? 20. We will compare 10 and 20. We will compare 10 and 20. So 20 will become the root node. 20 will become the root node because root node. So we will compare with the 20. We'll compare with the 20. So it is not balanced. It is not balanced correctly. So we will modify like this. We will modify like this. We will place 20 first and we will place 10 to the left. 10 to the left. Why? Because 10 is lesser than the 20. 10 is lesser than the 20. So this is a we will convert. This is a we will convert. So now the root node will become, the root node is nothing but 20. So next we'll compare with 30. Next we'll compare with 30. So 30 will become the root node. 30 will become the root node. Next 10, 20. 10, 20. So 30, and to the right, we will place 40 and we will place 40 to the right 50. 40 to the right 50. So this is how the graph look like. This is how the graph look like. For example, so all the left subtree element, all the left subtree element should be lesser than the root node. All the left subtree element lesser than the root node. All the right subtree element should be greater than the root node. So 30 will become the root node. To the 30, 10 is lesser than. So we will place into the left side, and 20 is lesser than. So we will place inside the left side. The 20 is the greater than to the 10. The 20 is greater than to the 10. So that is the reason why we are placing into the right of the 10. Right of the 10. And 40 is greater than root node. So we are placing in the right side. And for to the 40, 50 also greater than. So we are placing again in the right side. So only one thing, all the smaller values will be placed in left side. All the greater than values are placed in the right side. So this is how we will construct the tree. This is how we will construct the tree. So after constructing the tree, you have to visit every node in the tree. You have to visit every node in the tree. So visit is nothing but we have to go to the particular element. We have to go to the particular element. The element is called as in a tree a node. We have to go to the each and every node, and we have to process. So this is called as a tree traversal. A tree traversal. What is the meaning of traversal? What is the meaning of traversal? So in a tree, all the nodes must and should be visited. In a tree, all the nodes must and should be visited. The process of visiting all the nodes, is called as a tree traversal. The process of visiting all the node is called as a tree traversal. Okay. So there is a root node, there is a left subtree, and there is a right subtree. All the left subtree elements should be lesser than root node. All the right subtree elements should be greater than root node. So what is the meaning of tree traversal?